Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. Dear students, Assalamu alaikum. Students, I am Abdul Qadir, your physics teacher from Army Public School and College, Ruhe Rawa, West Street 3, Rawalpindi. This video lecture is for class 10th, subject physics, lecture number 2, unit number 10, simple harmonic motion and waves. And today's our topic is motion of a mass attached to a spring. Prior knowledge, introduction to the simple harmonic motion, which I discussed in the previous video lecture. Today's learning objective at the end of the lesson, students will be able to know about the motion of mass attached to a spring. Students, let's revise the definition of simple harmonic motion. Simple harmonic motion occurs when the net force is directly proportional to the displacement from the mean position and is always directed towards the mean position. Students, in this definition, when you apply a force, then the body will cover a displacement and that displacement will be directly proportional to the net force and it is from the mean position. And students, the direction of that motion is always, or you can say the acceleration will always towards the mean position. Students, there are different systems which we are going to discuss related to the simple harmonic motion. Simple harmonic motion of different systems. One is motion of mass attached to a spring, ball and ball system, motion of a simple pendulum. Simple harmonic motion, motion of mass attached to a spring. Students, this is our today's main focus. So students, I will discuss this. For that, students, open your textbook, page number 2, so that I can explain it from your textbook. Dear students, motion of mass attached to a spring. Now students, this topic, how you will answer this topic. Students, there are two important things in this topic. One is the diagram, the second one is the mathematical form, and the third one is the explanation. Explanation stands for the things which you are going to write, which you are going to draw. You have to just explain them in your own words. So students, let's find out what is happening in this diagram, the figure 10.1. Students, it's a very easy. In A figure, you can see it, there is a spring and the one end of the spring is attached to a mass and other one is with a fixed point. Students, in the A figure, there is no motion, so there is no simple harmonic motion or you can say the oscillatory motion, because there is force equal to 0. When the force is equal to 0, then the displacement will obviously equal to 0 because the body will not displace from its actual position. And now students, here you can see it, there is x and there is an arrow in A figure and that indicates the displacement will be in this direction. Students, O point indicates the mean position and B and A are the points which are extreme positions. So students, firstly I will just displace by applying a force the body to the A point from O, and then I will release this body and that body will start oscillation. Students, in the B figure, what I did, students, I applied a net force and this body which was at point O comes to the point A. And now students, there is another force which is a restoring force which actually try to restore the actual position of the this spring system. Students, as I release this body from A point, this body will come to point O, and again after coming to the point O, it will shift to the point B according to the figure C. Students, here you see the new position of the body which is at B. Students, from O to A, the body covers the displacement which is x. Let's see this. Here you can see this, the red colored X shows the displacement which is from O to A. Now students, as the body reaches from point A to B, again a new restoring force appears, and this restoring force actually the reason which is producing the oscillation. And students, this is the process, that's how the oscillation happens in this spring systems. Students, let's find out that according to the mathematical form whether it is right or not. Students, according to the Hooke's law, this force is directly proportional to the change in the length of x. So force is directly proportional to the x. So as 10.1 mathematical form or relation, F equal to minus kx. K is the constant, you can see the spring constant, and x is the displacement, and minus sign indicates that there is a restoring force which is in opposite direction of applied force. Students, I just rearrange the figure 10.1. The K will remain at its position, and I will shift the sign, negative sign, and the displacement to the other side. And new form, this is a spring constant, K equal to minus Fx. Student, according to the Newton's second law, F equal to ma. So I just put the value of F in the above relation, and the above equation will become K equal to minus max divided by x. Students, as I'm going to find the acceleration in the simple harmonic motion, so I will separate this a equal to minus k over m into x. Students, k is the constant, and as m is the mass which will not change, so it is also a constant. So students, this is the acceleration directly proportional to the displacement. So students, that is it about the mass attached to motion of a mass attached to a spring. Students, in this topic mathematical form is very important, and the diagram, you have to label the diagram as well, and little bit explanation which you will do in the mathematical form. Dear students, move to the page number 3. In this page there is a diagram for your information. Students, in this diagram you can see that there is a mean position and extreme position. Students, remember this. In a spring system, at mean position the kinetic energy will be maximum because of inertia, and the potential energy will be 0. And students, at extreme position kinetic energy will be 0 because the body stops for some seconds to return back to the previous position, and potential energy will be maximum because of change of position. So students, that was, and we can write it the displacement at O point x equal to 0, and at A point it will be positive, and at the other one it will be minus a because of the restoring force. Dear students, at page number 3, there is another relation T equal to 2 pi under root mk. Students, this relation is a time period of simple harmonic motion of mass attached to spring. The derivation of this mathematical form or the relation you will study in the next classes. In your grade at 10th level, there is just a relation for this. Student, capital T denote the time period, and 2 pi, the value of pi is 3.14 or 22 over 7. M is the mass and K is the constant, or you can say the spring constant. Students, whenever you are asked to find the time period, then you will use this relation. And dear students, recapitulation, today we have discussed about motion of mass attached to a spring. Your assignment, students, understand and write the motion of mass attached to a spring, because this topic is very important. Thank you, dear students.